Hi everyone. Today we will see regarding binomial distribution. Before going to know about binomial distribution, we need to see regarding something called random variable. Random variable. You already studied in your third semester random variable, mathematical expectation and so on. But here I will tell you in short. Random variable is a function where it will assigns random variable is a function which will assign a real number to a sample point to each sample point in the sample space. So here you need to understand a random variable is assigning 1 2 3 4 5 6 like this. It will assign a real number to each sample point in the sample space. For example, we denote sample space by s, that is 1 2 3 4 till n. So here a random variable is like this. Then there are two types of random variable. There are two types of random variable. First one is discrete random variable. Discrete random variable, assume that you have x1, x2, x3, x4, x5 till xn values. Probabilities p1, p2, p3, p4, p5, pn. When you toss a coin, then there are two things, head and tail. Or if you take an example of random variable, number of male children in a family of having a three children. It may be there may be no children, that is zero male child, one male child, two male children, at most three male children. So there may not be a male children, there may be one child, there may be a two children. Is our second type of random variable is continuous random variable. Continuous random variable is a type of random variable. Here it will take any number. Say for example, weight of an apple. If you differentiate these two random variables, if you take a same example here, you may take number of apples in a box, maybe one apple, two apples, three apples, four apples. Here if you take a continuous random variable, weight of an apple, then height of a student comes under continuous random variable. Number of students in a class, it may be a discrete random variable. Or number of markers in a box, that may be a discrete random variable. And the weight of a particular marker, it may be continuous random variable. So now you got a differentiation between discrete random variable and continuous random variable. I will rub this. Then there is something called theoretical distribution. Then there are three types of theoretical distribution. We can classify the distribution or a theoretical distribution. There are three types. The first one may be binomial distribution, and second may be Poisson distribution, and third may be normal distribution. See here, theoretical distribution, we have three types of theoretical distribution, that is binomial, Poisson and normal. We will be discussing in first chapter these two distributions, and in third chapter this normal distribution. So binomial and Poisson distributions are discrete random variable, discrete theoretical distributions, and normal distribution is continuous random variable or continuous distribution. These two are discrete theoretical distributions, and this is continuous theoretical distributions. Then in today's class we will see regarding the binomial distribution. Binomial distribution is popularized by or discovered by a Swiss mathematician James Bernoulli in 1700, that is 18th century, entry of 18th century. A binomial distribution, it is popularized by James Bernoulli. Then a binomial distribution is a discrete theoretical distribution which has the probability mass function PMF, which has probability mass function, that is probability of x equals to ncx into p raised to x into q raised to n minus x. So this is a probability mass function of binomial distribution, and this is the formula to calculate the binomial distribution. Then if you see features of binomial distribution, it is very important to know features or characteristics, where you will be asked for 5 marks about features of binomial distribution. Very important one, features of binomial distribution. Then here first thing is n and p are parameters of binomial distribution. N and p are parameters of binomial distribution. There are two parameters of binomial distribution, that is n and other one is p. Then a second feature of binomial distribution is x equals to 0, 1, 2, 3 till n is the range of binomial distribution. So it is a discrete random variable. It takes values between 0, 1, 2, 3 till n. So that is what the range of an binomial distribution is 0 to n, infinite. Then the third feature of binomial distribution is in binomial distribution or for binomial distribution. I will write in a short, that is binomial distribution mean equals to n into p. Mean is n into p. Then variance equals to npq. Then standard deviation equals to root npq. So if we see for the purpose of binomial distribution, the mean is n into p, that is np. Variance is n into p into q. Then standard deviation is root npq. Then fourth one, mean is more than variance. Mean is more than variance, that is np is greater than npq. np is greater than npq in case of binomial distribution. And fifth one is p equals to q equals to 1 by 2, that is p and q are the parameters of the p is a success of an event, q is a failure, happening and non-happening. So both are equal, that is 1 by 2 of in the binomial distribution. Then it said is binomial distribution is symmetrical. Binomial distribution is symmetrical. Then sixth one is binomial distribution tend to be Poisson distribution where n is very large and p is very small compared to n. That is n leads to infinite and p leads to almost 0. Then np, that is mean, we denote by lambda. N is infinite and p is almost 0 or near to 0. There we can calculate the mean of Poisson distribution is denoted by lambda. These are 6 features of binomial distribution where n and p are parameters of binomial distribution, where it is very easy. There are only 2 parameters. They will ask for 2 marks. What are the parameters of or binomial distribution? So you can simply write that n and p are parameters of binomial distribution. Then x, which will take the values of 0, 1, 2, 3, 4, 5, 6 till n, is the range of binomial distribution. And for a binomial distribution, mean equals to n into p, variance is npq, and standard deviation or sigma is root npq. Then in binomial distribution, mean is more than variance, that is np is greater than npq. Then p equals to q equals to 1 by 2. then we call, or a binomial distribution is symmetrical. Then binomial distribution tend to be a Poisson distribution, where is n is very small and n is very large and p is very small. In that, the mean represent for the Poisson distribution is np equals to lambda. So you can write these things. Have you written? Can I rub it? I will rub it. 5, 4, 3, 2, 1, 0. Yes, we will see the simple problems of binomial distribution. Simple problems where we will calculate NP, NPQ, variance or standard deviation like this. So there is a problem like this. In a binomial distribution, if n equals to 6, p equals to 1 by 3, find mean. It is a very simple problem. They will ask for 2 marks. That is, they are mentioned here in a binomial distribution. BD is binomial distribution. If n is 6, p is 1 divided by 3. Find mean. Then we already seen in a particular features of binomial distribution. N and p are parameters of binomial distribution. Then mean of binomial distribution is np, that is n into p. So where mean equals to n into p equals to, we need to find out this, that is n is 6 multiplied by p is 1 divided by 3. 3 ones are 3 twos are. So 2 is the mean of binomial distribution. We can write here mean of binomial distribution is 2. So it is very simple. Here they asked you to find out the mean. The mean of binomial distribution is np. So n into p. They are given n and they are also given p. If you insert the values of n and p, then we will get a 2. So you can write this. You can pause the video and you can write this.